Hey folks, I am live here with Lama from Intel. Now Lama, you have been working with the great Stephen Hawking on what sounds like an amazing software project. Why don't you tell us a little bit about yourself and the project?
Sure. So I'm Lama Nachman. I actually run a lab at Intel Labs called the Anticipatory Computing Lab. And we do all sorts of work with sensing and sense making and developing really cool applications and experiences enabled with that data. So about 4 years ago, we actually got to meet Professor Hawking to try to see if there's something that we can do to actually improve his communication system. Mm-hmm. And basically what Stephen has is this system that actually enables him to do anything with his Windows machine, right? So any application, etc., through a very limited interface. And in his specific case, it's actually a proximity sensor that sits on his glasses, and every time he actually moves his cheek, it actually triggers that sensor.
Oh, interesting, okay.
So basically, the task was really, can we enable him to do everything in terms of, what we actually do every day, right? So, edit documents, give lectures, surf the web, talk to people through that one sensor.
And so you got to work with him directly, and he was kind of giving you the input for how to control the software?
So basically, he gave us a lot of input in terms of, from a designer standpoint, like if one wants to design a system, what would he like to see in terms of capabilities? So a lot of that information we got from him, but we also got a lot of information from people that actually worked with him, as well as just by observing him. We recorded like hundreds of hours of videos, watching how he was using his whole system and trying to figure out how can we actually improve on that.
That's so cool. And so how does the software actually work? You do face tracking, gesture tracking, or how does it work?
Right, so the system that's actually for Stephen, which is what we try to do with open source, then open it more up than that. But for him specifically, the sensor is a proximity sensor.
Okay.
So the way a proximity sensor works, like for example with your phone, right? When you bring it next to your face, the proximity sensor detects that proximity and then just disables the thing. It's the same thing, right? So it's actually a proximity sensor that sits on his glasses. So every time he moves this cheek, which is the muscle that he's able to still control very well, that distance will become shorter, right, to the sensor, so it will trigger a trigger.
Is it fine-tuned, meaning like is it just on-off, or is it fine-tuned, meaning like the more, okay, got it.
It's on-off, so essentially it's a binary switch. If you think about it, it's the same as a push button, right? And what you have is a timed interface. So imagine something that just keeps moving on maybe different letters or different menu items, and when it gets to the thing that he's interested in,
then he
clicks the sensor. And
okay, do you do anything with eye tracking as well?
No, actually we did try to use eye tracking because it seemed like it would be a great technology, but for him it didn't work because his eyes actually droop. And that's actually very typical of people with ALS. So it's really very hard to actually lock on the gaze. And we've actually worked with other patients where there's a lot of movement in the eye. So eye tracking technology works for some people, but not for everybody.
So as people try to understand the application now, we kind of put you on the whiteboard on the spot here. How does it actually work quickly? Okay,
so basically, really what you have is, imagine there are a few different things that we're trying to do, right? So imagine a keyboard, a virtual keyboard, right? And in that keyboard, what you have is, that layout, and the timed interface starts to actually actuate the different letters or the different rows, right?
Right.
And when, so imagine here, you could have any type of a sensor. You could have like an IR sensor. You could have, you mentioned, gaze tracking or whatever.
Sure.
We actually even tried accelerometers and stuff like that. So you could have any of those sensors which get controlled by what we call an actuator.
Okay.
Right? And so that is just responsible for really decoupling whatever the sensor is from the rest of the system.
Awesome.
Right? So now we can extend it to anyone who can maybe move, a finger, or somebody who can move an eyebrow or whatever.
The next sensor system plugs right in.
Exactly. And then basically what you have here is all of these different core libraries that we call, right, which are responsible for things like maybe creating a completely new UI. Right? For some people that might make sense, what Stephen had. For others, they might want a completely different UI.
Sure.
So everything essentially becomes a plugin. Right, and that's what really enables the expansion of that system to a lot of different users.
Awesome. That is so cool. So how do you go about testing software like this? Is it just, I feel your exhaustion.
It's a very tough thing. And, honestly with Stephen, because we would go and come up with all sorts of different things, right?
Sure.
And then we'll put it in front of him. And I think one of the things that he loved to do was actually find bugs in our software. So we started calling him, a validation engineer on the project because, he would start doing something. And, to the point you were really trying to highlight is the way he uses the system is very different than the way we would think about using it from a testing standpoint.
Right.
So, we would put it in front of him and he'll, right away find the bug and give me this smile on his face. I'm like, I found you again.
Oh my
But
goodness.
yeah, the debugging was, through, a lot of rigorous debugging that we could do, but also his carriers, for example, will test things that they knew was very important.
So, for folks who want to learn more, what website should they go to?
Yeah, so you should go to https://01.org/ACAT, ACAT, which is Assistive Context Aware Toolkit.
Awesome, Lama. Thank you so much for your time. This has been so cool.
Thank you.
Thank you.